Hello grade 10s and welcome back to trigonometry. Today we're carrying on with a concept that is very similar to yesterday, where we are applying our three trig formulae, being sine theta, cos theta and tan theta, except today we're going to practice finding the size of an angle when you are given two sides, such as this triangle over here. If we had to find theta, we would need two of the three sides of this triangle in order to find the size of that angle. Why? Because each formula has three parts. If you are given two of the three parts, you'll be able to find the third part. What do I mean by part? I mean that sine theta over here will have a theta part number 1, a side of a triangle, part number 2, and the other side of a triangle, part number 3. So those three pieces of information are interlinked, and if you have two of those three pieces of information, you'll be able to find the third part. Let's remember that the side directly opposite theta in a sketch is called the opposite. The side directly opposite the 90 degrees in a sketch is called the hypotenuse. And then the third side would be the adjacent. It is definitely easiest to first identify the side directly opposite the angle you're working with, and then the hypotenuse, and then you can conclude, okay, whatever side is left over can be called the adjacent side. Last but not least, remember that that third angle in a 90-degree triangle will be the subtraction of 90 minus theta if you are given the size of theta. Okay, so let's apply our knowledge. First things first, when you're dealing with a right-angled triangle, you must think Sohcahtoa, easy peasy. Now, let's mark off the information that we've been given before we are able to find the size of alpha. Note the symbol of alpha. In trigonometry, we speak about, we use a lot of Greek letters for the symbols of angles. Right, so we are asked to find the size of alpha, and let's now see what have we been given. Let's tick everything we've been given in the formula in one of those three formulae. Okay, so we've been given 1,5, which lies opposite alpha. So any formula that has an O for opposite, I'm going to give a tick. There's the sine alpha formula and the tan alpha formula. They have an O in it. But what is the other piece of information that I've been given? Do you see? It's the side that lies opposite the 90 degrees. It's the hypotenuse. So let's go tick every formula that has an H for hypotenuse. Now the formula with two ticks is the one we must use. So we can jump straight into saying sine alpha is opposite over hypotenuse, which is 1,5 over 2,1. Now remember, when we are looking for the size of an angle, we need to whip out our calculator and press shift. We need to use the inverse function of sine, the arc sine. So you press shift sign, pop 1,5 over 2,1 into the calculator, and you should get 45,6. Do not forget the degrees symbol, please. Righty, grade 10s, let's try this example here. This triangle is like a right angle triangle that's been reflected or rotated, but Sohcahtoa still applies. So let's have a look at the two pieces of information we've been given, and let's tick the appropriate letters in our three formulae. If you have a look at alpha, what is alpha's relation to 25,6 and the 30 that has been given? It's quite obvious to see that 30 lies directly opposite the 90 degree. So 30 is your hypotenuse, and so I'm ticking my formulae with the letter H for hypotenuse. Now, what is that 25,6? Is it the opposite or is it the adjacent? Well, if you look directly opposite alpha, you'll see the opposite side has not been given as a piece of information. So 25,6 must be the adjacent side. And that's why I'm going to put a tick next to A for adjacent in my list of formulae. Now we can see that cos alpha is the one with 2 ticks, so that is the formula that we apply. Cos alpha is adjacent over hypotenuse, and we can substitute in the relevant information, 25,6 over 30. Now to get alpha all by itself, we use the inverse function of cos on our calculator, so press shift cos, and then pop in the fraction and press equals, and you will get 31,4. Last example for the day. Here we are asked to find the value of beta and alpha. So this angle right here, it looks like a B with a longer tail. That is called beta. Alpha, I'm going to introduce a little later on. For now, I want to keep it simple by having you see that beta can be found using Sohcahtoa because we've got a right angle triangle. So let's have a look at the information that's been given. We have 3, which is directly opposite to beta. So wherever there's an O, I give a tick in my 3 formulae. Right, what about 5,3? Do you see that it's directly opposite the 90 degrees? So I have the hypotenuse, and so I am ticking each formula that has an H. Here we can see that So of Sohcahtoa is the one with 2 pieces of information, so that is the formula that I am going to apply. Sine beta is opposite over hypotenuse. Opposite is 3, hypotenuse is 5,3. To get the value of beta, we press arc sign or shift sign on our calculator and equal, and we will get 34,47. This has been as straightforward as the previous 2 examples. However, and I want you to take note because this is similar to the question E that you are getting in your homework today. What if I wasn't as kind? What if I didn't ask you for beta and I actually asked you for alpha? Do you see that this sketch has suddenly become a little bit more complicated, and we now have a big right angle triangle called ABD? ABD has alpha in the one corner, 90 degrees at the vertex there by A, and beta at the other vertex there by B. We've already calculated what beta is. We know that this is 90, so surely we can work out alpha using the interior angles of a triangle. We take 90 at A and 34,47 at B away from 180 because all 3 of the angles are meant to add up to 180, and we end up with A is 55,5 degrees. And don't forget to put a reason, interior angles of a triangle. With these examples, you should have the tools you need to tackle today's homework activity. It shouldn't take you more than 20 minutes, and it shouldn't take you more than 2 pages. Note that it's sometimes helpful to draw the triangles so that you can make marks on them as you do your calculations. And please remember to check the memo should you have any queries, and if the memo doesn't make any sense, please feel free to reach out to me or one of your teachers. Enjoy.